This portion of the presentation will go over the use of a flaring tool to flare at the end of a copper tube. When using a flaring tool, first ensure the tube end to be flared is properly reamed before attempting to flare it. This will ensure a smooth, even flare is created. The tube is then clamped within the flaring block on the flaring tool, with the end slightly above the chamfer. A screw-type yoke is turned, which forces a cone-shaped adapter into the unflared tube. This action creates the flare in the tubing. 45-degree chamfers are most commonly used to create flared ends. Be careful not to over-tighten the cone, or else cracking or deformation of the flaring tool can occur. This in addition to creating a poor quality flare. This is a picture of a common flaring tool. Picture A shows an unflared tube being held in a flaring block. Picture B and C show the tightening of the screw-type yoke, which forces the cone-shaped adapter into the unflared tube, creating the flare shown in the fourth picture. Also, take care not to extend the tube too high above the chamfer when using the flaring tool. This creates a flare that may be too wide, which will affect the connection of the flare to the fitting. The ideal flare produced should be smooth, even, and round. This flare should have sufficient length to provide full contact with the mating surface, while not interfering with the threads of the fitting.
First, place the flaring nut on the tube. Then, clamp the tube in the flaring block, leaving part of the tube above the chamfer. Tighten the wing nuts. Make sure the flaring nut is on the tube. Attach the screw-type yoke to the flaring block. Then, tighten the screw, making sure not to over-tighten. Unscrew the yoke and wing nuts. This is your flared tube.
Flared fittings are designed for higher pressure systems, producing a pressure-resistant, leak-tight seal. Flare connections offer a high degree of long-term reliability. Flare fittings are available in a broad range of sizes and configurations, which include caps, plugs, unions, elbows, adapters, and tees. For this installation, the components required will be a nut, fitting, thread oil, and 2 adjustable wrenches. To install a flared fitting, slide the nut into the tube with threaded end facing outward. Next, after flaring the tube, thread the flare nut onto the fitting. Use lubricating oil to ease nut assembly. Next, use 2 wrenches to tighten the connection. Be careful to not over-tighten the connection, as this may cause damage to the flare or fitting. Next, attach tubing to the other end of the fitting and check for leaks. If leaks are present, check nut and fitting for tightness.
Isolation valves or service valves are used to service appliances without having to isolate water supply. For a half-inch copper tube, a 15mm isolation valve with compression ends is needed. The body has a taper in which the olive sits. From left to right, the components of a compression valve are 2 compression nuts, 2 olives, a valve body, and a copper pipe. The installation tools are a monkey wrench, water pump pliers, a hacksaw, or a pipe slice. A pipe slice is preferred, but if the pipe is against the wall, a hacksaw is required.
In order to install a compression fitting, one needs to remove the correct amount of pipe in order for the valve to fit and function correctly. The first step in cutting the pipe is to label the pipe with the section that needs to be removed. A paint marker is used to label the copper pipe at the beginning of the threads located on each side of the valve. Once the pipe is marked, one needs to physically cut the pipe. A pipe slice is preferred because it creates a straight, burr-free cut. Joints are far better if the two pieces of the pipe to be joined are square and burr-free. If a pipe slice is not an option, a hacksaw will suffice, but it will be difficult to make a straight cut. In order to use a pipe slice, open the pipe slice and close it onto the pipe. Then rotate in the direction of the arrow on the pipe slice. Alternately, cut the pipe with a hacksaw, making sure to cut along the marks made. Now that the pipe is cut, one slides the two compression nuts onto each piece of the pipe, followed by the two olives. Next, one places the valve into the two pieces of pipe, ensuring that the arrow on the pipe is pointing in the direction of water flow in order for the valve to function properly. Now one pushes each compression nut onto the valve and tightens by hand. After the compression nut can no longer be tightened by hand, a pair of water pump pliers is used to hold the body of the valve, while the monkey wrench is used to turn the compression nut another 3/4 of a full turn. Now we check for leaks when the water is restored. If leaks are present, tighten compression nuts a little bit more until no further leaks are detected.
Hi everyone. Today we'll be talking about the process involved in fitting a tubing joint. So here are the list of the materials that are needed to perform the operation. We have the copper pipe by itself, the copper fitting, the propane surge, the flux brush, the hacksaw, the sandpaper, the wire fitting brush, the tool, and the vise. So the next couple of slides we'll be talking about the process involved. It actually takes about 6 to 7 steps to perform the operation successfully. So the first thing you want to do is you secure the tube in a vise and cut it along the line where you want the copper.
Remove some excess of material tip by using a brush to make sure that all the cutting that you just made are clean.
So after doing that, you want to clean the inside and the outside of the pipe with a piece of sandpaper to get rid of all the debris and the next operation.
Apply the soldering paste all around the surface that you just cleaned so that it will allow a smooth and nice contact between the two elements.
So after doing that, the next thing you do is you attach the fitting to the pipe, the soldering flux. You bring it a little bit close to the fitting, but you have to make sure it's not too close, otherwise you end up burning the fitting and then cut it, and then you end up with a bad joint.
After operating the two elements, make sure that you apply the lid, which is the soldering element between the two pipes, all around the surface.
So if that process is followed properly, then you should have a very good joint. So the last thing you want to do is clean the surface that you just soldered. Just clean both on the inside and the outside. The process involved. Thank you.